Only that it's nice to come to nice events, and this is by its very definition a nice event. If this is working, then I don't need my own. So what I have prepared is a set of slides which I don't intend to speak of about all of, but I did think they might be useful to leave, in part because I'm going to be echoing in a kind of more concrete way a great deal of stuff that both Andrew and Tony and indeed Barney have already alluded to. Where is the full screen? I tried Control L over.
Other side of the screen. Just arrow there. Keep going. Keep going.
Oh, there it is. Yeah. No?
Control L.
I tried Control L. Can somebody open it for me? I want to keep talking. One of the things I learned, because I spent, believe it or not, the last 25 years of my life talking about mathematics and technology, is learn when to bail out early. I actually had a wonderful class 10 years ago where I taught a classical math analysis course out of Stromberg, but in a lab with Maple and MATLAB and other things. And for 4 weeks, I had 6 students in a graduate class in user interfaces studying my class for their major term project. And for 2 weeks, I had a postdoc for mathematical education studying the user interface class, studying my class, studying me. And it was a little Escher-like, but I discovered I only wasted 3% of the time on technology, which I thought was great. And most of the message was, when in doubt, quit. So I was recruited by Bonnie Glover in late 2007 to Australia. I first started visiting Australia over 25 years ago. So by the time I moved, I actually thought I knew the system much better than I do. But I had lots of friends and colleagues. I'd met Tony and all the people at AMC. And so it made the move seem possible. So these overheads will be up and they link to some other things. I wanted to explain the talk. It's completely with a rip-off. I had the great privilege of hearing Chandrasekhar and others speak at the 100th anniversary conference for Ramanujan. And most of the talk, and Freeman Dyson was there, and Sunita Dyer, and Chandrasekhar gave a most erudite and elegant talk, and it's wonderful to see these people in the flesh. And then Erdos, whom I've actually known since I was a baby, stood up and he said, "My title is Ramanujan and me." So it's not quite that balanced, but I want to talk a bit. First of all, I want to congratulate you. There's a quotation due to Michael Faraday and the Royal Institution, which is a research center, is a place where second-rate people do first-rate work. And of course, when you say it, it sounds insulting, but I know I'm second-rate. Yeah? There are very few people who are first-rate for a Faraday. The real key to a collaborative environment is you are more than the sum of the parts. And I think that's where you start. I have a minor suggestion that you start using an A in front of your name. Australian Centre for Research Mathematics, because there's a CRM in Montreal with a 30-year lineage and a CRM in Barcelona with a very vigorous program. And I think individuating is good. So fit an A in somewhere, A, as we say in Canadian.
You don't use too grandiose to use Australian Centre?
Well, work out a way to do it. But I think differentiating yourself early is non-trivial. I was flabbergasted. I've had some fairly arcane names for centers in Vancouver, CECM, Centre for Experimental and Constructive Mathematics. I was amazed at how many centers for ecclesiastical Christian missionaries. The world is highly acronymed, and if you can get yourself targeted, you don't have to really worry about competing with a group that's sending missionaries to Somalia, but probably better to not be assumed you're an outlier of 2 older centers. These are the things that are on these overheads, and I'm going to sample from them. This is the home page for our center. It's undergone many evolutions, but the week's events, the next 8 days always show up. News, so we're very pleased that George Willis was elected a fellow of the Australian Academy earlier this year. And since we have now inherited Richard Brent, because his wife is one of our faculty members, we have something like 3 of the 9 fellows of the Academy in our center. I think that's wonderful, because although I endorse everything that Tony said about the need to do things, I also endorse what he said about the very large AMC tail wagging the AMC dog. And it's absolutely key that as you go on, the caliber of the research, and that's not the same as having 4 fellows of the Academy, but the caliber of the research has to be central to what you're doing. If you become a way of satisfying your senior administration, who may not all have the good taste of Bonnie Glover, that really the only good measurement is more linkage grant dollars, you won't have much fun, you probably won't succeed very much, and you certainly won't be making the case for our subject. The Carma leadership, well, I'll show you the total numbers, but there is Judy Ann Osborne, who's also Mrs. Richard Brent, and you might notice this man. Tony Goodman is on our advisory committee. We have an advisory committee of 3. David Bailey spent his entire career at NASA and Department of Energy Lawrence Berkeley Labs. He's now a research fellow at UC Davis. Jerry Joseph has a PhD in functional analysis from Newcastle, but he spent his entire career at IBM. And I think in terms of an advisory group, you really want people who care enough about your institution. That's why I was delighted to have the connections with Tony. I believe only 4 people have occupied the office that I'm presently in, and Tony was one of them, and Ian Rayburn between us. And I think that it's critical. Jerry, for example, is passionate about helping us. He's also in Canberra. He goes to events with the university in Canberra, and I think we're being very well served. And Tony didn't mention one other important role. That's as a whinging board. However successful you are, you're going to be told no more than you'll be told yes. And you're going to see things that in the short term aren't working. And it's very useful to have the sanity check of having such experienced, knowledgeable, and erudite people as Tony and the rest of our board to say, listen, am I actually completely out of line? You know, am I living in the wrong universe this year? And that's an important job too, because the challenges of doing this, I'll come back to that, are substantial. I should say with the web page, it took me 2 years and almost a threat to resign to get to a point where we could run web presence where we had something resembling root access, which I had always had at my previous institutions. Because without that, you can't send a message to the Central Improvement of GUI group as a subset of finance and human enrichment. A fine group, by the way. And expect to ever have any sense of keeping a real information flow being useful to your members. You have to be able to control that. And in most institutions, find that very hard to deal with. We've been lucky in the last 3 years, we've been given 3/5 of a person to look after our access good resources for teaching. And I'll come back to a few of those things. Access good is a misnomer. That happens to be a technology that was adopted here. It's one of the very few cases in which I've done good inadvertently for myself. 2003, Tony was describing the request for proposals for the math education, and I was sitting next to Garth Gowdry at the major meet at the International Congress of Industrial Applied Math in Sydney, and he said, we've got this proposal, they want us to do something with technology and communication. And I said, well, we've just learned how to use this because I was involved in building what's now the Canadian National Computing Network. And I said, you should try this. And then, in fact, by the time the room was inaugurated in 2008 in Newcastle, I was there to be the beneficiary of my own completely at arm's length advice, because I had no idea I would ever actually be benefiting. But I would prefer that you use names like Advanced Collaborative Environments, ACEs, or Australian Collaborative Environments. Acronyms where you can change the letters at will are very, very good. Because if you make the mistake of letting people think you're asking only for brand A and they will say brand A is passé, they've got rid of you. You have to actually be talking about the concept and not the instantiation. This is how I described as Keith Devlin what experimental mathematics is, and I have a Center for Computer-Assisted Research Mathematics and its applications. So the core is the research enterprise, and the acronym is the first letter of those 5 words. It also allows me an incredibly bad joke. Anyone says, what brought you to Australia? I can say with a straight face, it was Carma. But this is how we described experimental mathematics in a book that I wrote with Keith Devlin 5-6 years ago. And it was quoted by the International Council on Mathematical Instruction in one of their recent studies of proof and proving. And I use not to boast, but to emphasize that when you're looking at something which is actually a little exciting and new, it's very, very satisfying to see it being taken up and a common currency being developed. Now here, by the way, is a wonderful list of the 10 most important algorithms of the 20th century. And I don't expect you to go through it, but I leave it there because it's fun. And if you say, where's Newton's method? And the answer is, these were methods found in the 20th century, not methods used in the 20th century. And as far as I know, the only one I don't use every week is the fast multipole method. One of the wonderful things that I like about the way we're using computing is that there is a notion of secure mathematical knowledge without proof. Now, this is particularly interesting in many areas of statistical mechanics and the kind of places in the enumerative combinatorics where my own interests bump into Tony's, because in these areas and corresponding areas of number theory, we pretty much know that a lot of proofs are we have no ideas for proofs. So you can spend 20 years not getting somewhere, or you can try to advance the subject in a more inductive, empirical way. And there's this marvelous set of algorithms. It was the second most recent of the top 10 algorithms of the 20th century, and it actually answers an algebra question. I give you sufficiently many floating point digits of n plus 1 numbers, beta and alpha 1 to alpha n. And I have an algorithm, thanks to Hillerman Ferguson. This is a picture of him doing his sculpture in science. Brilliant sculptor, but also absolutely first-rate computational mathematician. It answers this question. I throw the numbers at it, and if there is a non-trivial integer relation, it will return it, and if it's implemented correctly, it will say, if there is any relationship, its Euclidean norm is bigger than something outrageous. Though you have to have an intuition to know whether outrageous is impressive or not, because, for example, 2 to the power 100th plus 1 all to the power 100 is a pretty simple sounding algebraic number, but just compute the norm of the minimal polynomial in almost any norm, and it will be ginormous. So you have to read these things correctly. If alpha naught's not equal to 0, this is exactly answering the question, is beta in the vector space, the Q vector space over R, with those basis vectors. And if, in fact, beta is 1, and the alphas are just powers of a given number, you're answering the question, is alpha algebraic of degree no more than n? And the fact that you can do this incredibly quickly and exclude things is a wonderful tool. And Hillerman took these ideas and some others and made it into a career prize that my father endowed for the Canadian Math Society. It's actually 8 kilograms of bronze. I hadn't realized how heavy that is. I thought we ought to put in the prize instructions, a successful candidate will be healthy enough to accept the prize. Experimental mathematics is actually central to what we do. And this is the cover of my book with Keith, where we have mathematical gnomes pouring numbers into a crucible, and on the back page, if you looked, you could see mathematics coming up from the crucible. So it's the opposite of the original way we think of computers, symbols in, numbers out. This is inverse computation. But at the top, this is 3 pictures of a gibbon. And they're from the thesis of one of my students who was funded by a company called Packeteer, again, the sort of thing Tony was talking about, to look at visual perception on the internet. A decade ago, the company wanted to make smaller pictures. I said, surely in 5 years that's not going to be an issue. No, said the vice president of research, but you can make a lot of money in 5 years. And so what they discovered, and these are things that are hard to show on the screen through the printing, but in fact, the picture at the right, I think to most people looks way better. It actually is smaller. They discovered through a mixture of mathematics and knowing a little about the optics of the eye, something called a perceptual dip. What happens when you use things like JPEGs are that a certain level of blockiness actually balances out jaggedness, and the eye prefers it. So they got a patent for that. And in fact, Packeteer was the company that stopped Napster from drowning all North American universities by because it was viewed like a virus, and so they just niced it. They didn't get rid of it. They just said, oh, hello Napster, you can have the lowest possible priority there is. So David and I have written about these sort of things, Dave Bailey, my main collaborator, in the notices recently, so I leave that flag there. Now this is what I've described as our mandate. Mathematics is two things. It's a subject we all love, or the mathematical sciences are, but it's also the language of high technology, which is what a former president of NSERC, the ARC equivalent, called it. And so it's everywhere. And we need to articulate, whether it's from CRM, MASCOS, My Center, that ubiquity. And it used to be briefly that people used the term ICT, Information and Communication Technology. Now I think we all understand that most of the time we don't know which it is we're doing. So that's important too. And so we've got a mandate that has these sort of things, performing R&D related to these kind of issues, promoting and advising on tools. Well, some of these we do more of than others, to make the university a world-leading institution for these things. I think in relative terms we've been pretty successful, in part because we inherited a wonderful engineering school, so we've had a 5 in applied math in both of the ERA rounds. I will make a little bit of comment from having been on both ERA rounds, 2012 and 2010. You're much wiser to have a small, high-quality group if you want 5s than to try to do it at Melbourne or Queensland or Sydney. So being small and being nimble and having a supportive senior administration is more important than growing. So in its own deep history, I've had a co-evolution in my own career of symbolic numeric computation with experimental math over the last 25 years. That little picture at the right there is a massive fractal coming from some number theory. The picture took, the mathematics took about 5 minutes to compute and 3 hours to print. I haven't timed it now, but to do this sort of printing, you actually need parallel printers, and most people don't give you that. So as we do things more visually and on a larger scale, big data also needs big output. A lot of big data is big nonsense. I think a big role for centers like yours or ours is to talk intelligently about the changing fashions and themes, and to know enough to say, yes, but. So 30 years ago, my brother and I, for the first time, he's a mathematician too, ended up in our 30s working together. We wanted to have a minor work in fast computation, and it grew into 30 years of shared projects. So then, 10 years later, I moved and founded a Center for Experimental Mathematics, and one of the things we did in 1995, almost 20 years ago, was to build an interactive book. We phoned people like Ron Graham, Andrew Granville, an enormous number of really talented people on the boundary between math and computing who'd already written a neat article, and we said, how would you change it if computers were around? What would you do if you could draw pictures? What would you do if you could have algorithms? And we thought that within 5 years it would be dead and dusted, so we called it organic. This organic stuff rots, grows and rots. And we said we're not going to promise to maintain it after 1999. The only thing that is not still working is the Maple code. And the reason is because when I asked them in 1994, can I put Maple on the internet? They said, hey dude, you've got a site license, you can do whatever you want. And I said, I don't think that's the end of the issue. And 3 years later, the research vice president from Maple came and said, I should shut you down. I said, what do you mean? He said, well, University of Southern California is teaching all of its courses out of your interface. So that's another way in which we as mathematicians tend to understand, and as a group of mathematical scientists, where we know the statistics, we know the engineering. I have actually I'm willing to say, I've seen most of what's going to happen in these areas over the last 20 years. Mostly I haven't been wrong. That doesn't mean I can persuade our university. I went in 1994 and I said, if you gave me $200,000, we'd get really rich writing web pages. They said, oh. We never got really rich writing web pages, but other people did. So we opened various centers, and by 10 years ago, we converted a small center like you're opening now, Andrew, into 3,000 square meters of shared space for all computationally related research. Everything from the National Diabetes Center to computer algebra in one onion-like building. It's made it no easier to keep getting money. We got $25 million on one day, and people came out from all these groups and said, well done, well done, well done. And the guy from the Western Diversified Magpie said, thank you for thanking me, for congratulating me, but when we come back in 5 years to ask for a renewal, you will tell us to go away because it's boring and not cutting edge. And in 5 years, they told us to go away because it was boring and not cutting edge. So that's the challenge too. It's almost worse to grow too quickly and not be able to sustain it than it is to have a more measured view of this. So, so going into sort of advice for the leadership of the center, for all of you, you have to take reasonable risks, both intellectual and managerial. Is that a reasonable risk on the left? That's a 1948 picture of a man who then spent 70 years in the circus. The photographer said for him it was a reasonable risk. You have to be unreasonably persistent. Any senior administrator worth his or her salt will say no to most requests. Because if they say yes to most requests, they won't last even a full term. And if you're not interested enough to go back and re-articulate it, you will start with the most marvelous will. You couldn't have a more supportive VC, but that. And you have to have a clear set, and they simultaneously have to be attainable, but ambitious targets. And ambitious has to be calibrated. Anyone who tries to look for the Higgs boson at the University of Armidale is unrealistic. Anyone who says I'm in Armidale and therefore I don't have any interesting research I can do is both misguided and unambitious. So we currently have this sort of number of members. Members are from inside. I think we probably have now more like 16 associate members. But the university keeps changing its criteria for what these things should be internally and externally, but it gives you a sense of this, and it's been absolutely key to have some, if not full-time, dedicated 3 days a week or whatever, managerial people. For the first 3 years when you set something up, you can run on enthusiasm. But after a few years, that does not replace having a trained person. We have sort of 3 people. If we want to run a conference, I'd just say, let's switch on the conference machine, and I can come to you and say, what would you like to do at the workshop on algebraic genomics? And you don't have to say, where am I going to hold it? She'll come and say, these are the choices. And we run a fair number of regular colloquia and seminar series, including in education, which is actually, we're part of a several $million grant with Queensland and other places looking at improving the experience for high school teachers now. And I wanted to emphasize specifically, as I come to an end, the Access Grid series that are running. We used our Access Grid rooms 360 hours for seminars this year, or we'll have by the end of the year, sorry, for classes, 150 hours for seminars, and something like 30 hours for outreach activities. People speaking to industry, showing things in schools, and we offer now, we run on typically on Mondays, a mixture of an applied analysis and optimization and number theory. That's what we do. And some weeks it's on an analysis, and we'll have people from Macquarie and Queensland. Sometimes it's, or number theory, sometimes it's in optimization. We'll have people from South Australia or RMIT. We just switch on our room. And if you know enough either on a laptop or with an Access Grid room facility to come in, you're able to participate, ask questions, be involved, and we that way, we've now got a very strong group in combinatorics and discrete mathematics, and it's a very natural link. We're actually physically very close. Yeah. But nothing will build it like knowing that They run their seminars every Thursday. Thursday at noon, there's a seminar you guys can share. Maybe one time in 3 at the moment it comes from you, and 2 times in 3 it comes from us. And that, I would say, has probably been a single success. And then if you look over the last few years, I've been scheduling short lecture series. That's 3 or more lectures. The one that Joe Diestel gave has just come out. He gave 6 weeks worth of lectures on harm measures. It's just come out as an American Math Society monograph. So it kind of makes you realize we've been around for a while if we've got the whole throughput. And you'll see the kind of things. We're going to be running a workshop on financial charlatanism in July, and I'll advertise it, and I hope some people from here will come in. And we've also been able to run a lot of conferences now, and on the scale of ANSIAM, or 100 people meetings, or 20-person, 30-person workshops. And one of the things that I find the most effective way of using the money I have with my center is to say, if you want to run a workshop of 2.5 days or longer, I will guarantee $5,000 of seed money. You will know the workshop's going to exist. You can go out and nail down the first few things, and then the AMC connection, the OSMS connection, you know you've planned it, you know that 3 really top-notch people are coming. You go and you look for money from supporting people, including your institution, but it's for a concrete, not a, wouldn't it be nice if all those Fields medalists came kind of thing. And I really reference this, but I'll leave these things up. As I say, this is for you to come back and get a sense of the different things. And organizing our research material is something we struggle with. Every time somebody from outside comes and asks a question, it's always the case that you have 90% of the answer, but without doing a whole bunch more work, they can't find it. And I put a lot of premium on being able to answer questions, being able to write in the conversation, being able to get at the right person, but it doesn't matter how many times you've done it, they want a slightly different answer. And so to our members, we keep, this is getting right close to the end, remember their seed money, come and look at our events. Doesn't matter how many times you tell something as the manager, the organizer, the director, you have to think of it like a political event and do it 3 more times. And we have had some much less traditional things. Had a lot of work with, a lot of success with drawing number theory, and this ended up with a full-scale concert at our conservatory downtown. Started with Bach and Schoenberg, and ended up with our Walks on Pi and 3 pieces of electronic music. I thought it was going to be completely and utterly, kind of cliched, but it was great. And it sure did a lot of good, as Tony and to some degree Barney was mentioning, it did an amazing amount of good for our connections more broadly in the university. So I think, again, you have to aim slightly too high. You have to do what you both talked about, there has to be buy-in. I used to go out and try and get people to do things because it was good for them. Now I will tell everyone it's available, and I will actively help anyone who actually wants actively to be helped. And apropos of research and education, Elliot Phillipson, who was a former director of our National Health Research Institutes and then our Infrastructure Foundation, said explicitly, we're not allowed to fund education, but we are very heavily in favor of early introduction to research. And this is one of my favorite quotes because I use it as license for doing anything I want with education in our center. This is one to say. Yeah. And finally, when you're building a Blues Research Center, it's very hard work. Part of it is captured by this wonderful XKCD cartoon, things a university has on its webpage, people want to see, and the intersection, which is typically only the name of the school, and not always that. So it's got many hurdles, lots of details to get right, but if you do it as a group project and you step back enough and you don't just see the things that went wrong last month, but you see what's actually gone right in the last 18 months, it can be very rewarding, and I wish you a great deal of luck with the project.